So now we're going to look at the nitrate ion, and we're going to draw the Lewis structure for this. And the first thing we want to do is we want to count the total number of valence electrons. And we have nitrogen, which has 5 valence electrons, and we have 3 oxygen, which each have 6, for a total of 18 valence electrons. And note this negative sign over here. In order for nitrogen to bond with 3 oxygen atoms, in order for this to form a covalent bond, it's going to have to gain a free electron from somewhere. And if it gains a negative charge, its overall charge will be -1. It means it has one more total electron than protons. So we have to account for that. We have 24 valence electrons to start with. And now we're going to start with a single bond representing 2 electrons. Remember, the atom that is the least electronegative goes in the middle. Nitrogen will be less electronegative than oxygen because they're in the same period. But oxygen has another proton. There's no increased shielding, but it's drawing. Oxygen has greater nuclear pull for an electron. So nitrogen will be less electronegative. And we're going to start with a bond that represents 2 electrons. So how many valence electrons did we use? Well, each one of these is 1, 2, 3, 4, 5, 6. So really, we have 18 VEs left. And we're going to kind of fill them in. And we might as well, since we have 3 oxygens, just put 6 around each oxygen. And then we'll see what we need to do to get an octet. And that's exactly what we have right here. We put in our electrons. We put in 18 electrons, so now we don't have any valence electrons remaining. And what do we got to do? Well, we don't have an octet. All the oxygens have an octet. 2, 4, 6, 8. 2, 4, 6, 8. Nitrogen only has 6 though. So how can we fix this? Well, we're going to take a pair from one of the oxygen atoms and make one into a double bond. So it doesn't matter which one we do. We could take these and move them here, or we could take these and move them here, or we could take 2 from this atom and move them here and form one double bond. And that's exactly what we see going on here. And that's what happens. We move 2 of those oxygens in. Now nitrogen will obey the octet. Nitrogen has 8 valence electrons. And this is actually something called the resonance structure. And what that means is it didn't matter where I made the double bond. This could be a single bond here. I could have made the double bond here, or I could have made the double bond here and left this as a single. So resonance structure is just kind of the same molecule, but doesn't really matter where you make the double bond. It could change. So could have been either oxygen, either of the 3. So that's how we would draw that. Always count the total number of VEs to start. Start with a single bond, and then you just kind of want to move electrons until you get your octet rule satisfied. And we'll look at a little bit more that we have to do as we go on. We'll talk about formal charge, but for now, try to draw all of these molecules using these simple rules. And that's your assignment, and there are some rules on the bottom. Kind of remember the octet rule. All of these should obey the octet rule, and we're going to see some variations from the octet rule coming up in a few slides. We're going to talk about formal charge, but all of these should kind of follow that pattern. So do your best to kind of draw the dot structures for these diagrams. This is Mr. Sapone. I'm out.